This one is our other sorting technique called bubble sort. Why it is called bubble sort and what is the complexity of bubble sort, that we'll discuss now. So it is a simple sorting algorithm that works by comparing each pair of adjacent items. So we need to compare each pair of adjacent item or neighboring item and swapping them if they are in a in the wrong order. If they are in descending order, then we need to replace them. We need to arrange them in the ascending order. The pass through this list is repeated until no swaps are needed. So this will be repeated until no swaps are needed, which indicates that the list is sorted. So if no swaps are required, this means list is sorted. As it only uses comparison to operate on elements, it is a comparison sort. Although the algorithm is simple, but it is too slow for practical use. So in bubble sort algorithm, we need an input of array and output will be that sorted array. The output will be that sorted array. Now, this is the name of the algorithm, bubble sort, and this is the main logic behind this algorithm. That is, we need to compare every element with its adjacent elements. The a of j will be compared with a of j plus 1. If this one is greater, if the element at the left hand side is greater, then we need to do the swapping. So this is the logic behind the bubble sort. And how can we do swapping? We can swap using a temporary variable or a third variable. So this is how we do the swapping. We'll take this first variable, the value of this element at this position will be stored in temporary variable, and then at this position we can store the next element, and then at next element we can store this temporary value. So we need to repeat these steps from 1 to n minus I, and we need to repeat all these steps for 1 to n times. So this is how this you have already done. So the time complexity of bubble sort is, let's see how many loops are there. There is a loop inside a loop that will be equals to n square actually. So it is running from n to n. So order of n times will be taken by inner loop, and these all steps will take n square time because this is in loop inside a loop. So the complexity of bubble sort will be order of n square. We can also check the cost and times here. So what are the cost and time? For loop, if for loop take n time, the outer for loop take n time, then we can say the inner for loop will take I to n minus 1 time and multiply with C2. Okay, then these will take one time lesser than the outer loop, the inner loop, because these all are part of inner loop. So if we'll add all these, this will be the complexity of bubble sort. So that will comes out to the value of theta of n square. So n square is the value of bubble sort. Now what is the best case of bubble sort? So in best case, you can say there is a flag 1. If the list is already sorted, then in pass 1, if these are the elements, let's say these are the elements 12, 23, 34 already sorted elements, and I is this and j is this, and we will compare these two elements, but the condition will not be true because j is less than a of j is less than a of j plus 1. Then for j equals to 2, the same loop will run again and will never enter in this loop. For j2 again, these two elements are same, and for j3 these two elements are again will not be sorted, and j4 also it will not be sorted. So condition never becomes true, and if it never becomes true, what will happen? The value of flag, this flag we have written 1 will never become 0. It will always become 1. So we will not enter in this loop. So we can print here that elements are already sorted, and this is the best case we can get out of loop. Only one iteration take place, that is from 1 to n. Only one iteration take place, so the complexity will be n. And that's it about the bubble sort. And thank you.